Yeah, welcome to the 7th lecture of digital circuits. Here we are going to deal with codes. Okay. So generally, codes are classified into two. That is numeric codes and alphanumeric codes. Okay. So what is basically a numeric code? Here numbers are represented as a series of zeros and ones. So series of zeros and ones. Such kind of representation is known as numeric code. So what is meant by alphanumeric code? Alphanumeric code means here the code is represented using numbers. That means that is again in a series of zeros and ones plus this one alphabetic characters. Plus alphabetic characters. Okay. So that is you have alphabets and numbers. That is why it is known as alphanumeric codes. Now coming into classification of numeric codes. Numeric codes are classified as weighting code or weighted codes, non-weighted codes, weighted codes, non-weighted codes, self-complementing codes, sequential codes, then comes error detecting and correcting codes, error detecting and correcting codes, then a reflective code, and cyclic code. Okay, this is the general classification of numeric codes. Okay, this weighted codes. We have two types of weighted codes, namely binary code and binary coded decimal. This BCD can be represented again in 8421 form. You are having 8421 form, 2421 form, 5211 form, then 6311 form. You are having different forms of BCD representation. Non-weighted codes. Some examples are SS3 code, gray code, and 5-bit BCD code. 5-bit BCD code. That comes in an example of non-weighted codes. Now self-complementing. You can have self-complementing code. Some examples I will give it as 2421 code, 5211 code, SS3 code, etc. are examples of self-complementing codes. Now, sequential codes. Sequential codes, there are only two types. That is, we have 8421 code and SS3 code. Okay. Now, error detecting and checking. Here what we have is parity codes and Hamming codes. So, parity code, parity. We have parity code, parity codes, and Hamming codes. Now for reflective code, an example is you can have gray code. There is also cyclic code. The example is gray code. Okay. So this is the general classification of numeric codes. So each code I would explain it separately. Now coming into classification of alphanumeric codes. alphanumeric code. It is generally classified as, you can have some examples as ASCII code, EBCDIC code, and Hollerith code. Okay, so these are some examples of alphanumeric codes. So first we will start with numeric codes. Okay. So what is basically a numeric code? But I have already given the explanation of numeric code. What is a numeric code? In numeric codes, here numbers are represented as a series of zeros and ones. That is known as numeric code. Now, in numeric code, the first classification, what we can have is weighted codes and non-weighted codes. So first I will explain what is meant by weighted code, and then I will explain what is meant by non-weighted code. Okay. What is meant by weighted code? Here, in weighted codes, the weights are given to position. Or basically what happens is that this is a position weighted code. This is a position weighted code. Each position have its own weight. Okay. So non-weighted code means it is not driven by the weight of the position. For example, if you are having a BCD code is an example, binary coded decimal is an example of weighted code. So in weighted code, suppose if you are having 8421 code and the code is 1000. So see, each position is weighted. That means the first position is weighted 1, 2, next weight is 4, then comes 8. Now if you are having 5211 code, again you can have 1100. Here the first position is weighted as 1, then the second position is 1, third position is 2, and fourth position is weighted as 5. Okay, so these are the position weights. Okay, so here we need to study only with 8421 code. Okay, that is an example of binary coded, that is a BCD code or binary coded decimal. Now let me dive into this weighted BCD code. Okay, or simply you can write it as BCD code. Okay. Now, what is basically a BCD code? Here BCD code I am going to explain about 8421 code. This 8421 code. As already explained, it is basically on position weighting. Now, how you got this 8421? Okay, so we need to end the mystery of how you are getting that numbers or the position weights as 842 and 1. Okay, so if you are writing binary powers, it is basically a 4-bit code, and also it is basically a 4-bit code. So binary power. Okay, so this is the 0th position, first position, second position, and third position. So this is the position. Okay, so 0, 1, 2, 3 are the bit positions. So what will be the binary power? Here we will get 2 power 0. This is 2 power 1. This is 2 square and 2 cube. So what is the binary weight, or what is the position weight? What is the binary weight here? 2 cube. 2 cube you will get it as 8. 2 square it is 4. 2 power 1 it is 2. 2 power 0 it is 1. That is why we are taking it as 8421 code. Okay. Now let me show the conversion of decimal to, if you are given a decimal number, how to convert it into a binary coded decimal format, as well as if you are given a binary coded decimal number, how will you convert back to decimal format. Okay, so these two are the things we need to study in weighted BCD code or BCD code. Okay, an example I will show you. suppose, see, what is basically a BCD code? BCD code means binary coded decimal. Okay. So decimal means it is having only 10 values. So we have the values from of decimal and BCD. We have only 10 values. That means you have 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And already know that it is you already know that it is basically a 4-bit code with weightings as 8, 4, 2 and 1. So you can write it as 8, 4, 2 and 1. So 0 becomes 0, 0, 0, 0. 1 is 0, 0, 0, 1. 2 is 0, 0, 1, 0. 3 is 0, 0, 1, 1. That means 2 plus 1. You will get it as 3. What is 4? 0, 1, 0, 0. What is 5? It is 0, 1, 0, 1. What is 6? It is 0, 1, 1, 0. What is 7? 7 is 0, 1, 1, 1. 8. It is 1, 0, 0. What is 9? 1, 0, 0, 1. That means if you are writing this will be in the form 0 into 2 power 3 plus 1 into 2 power 4. Sorry, 1 into 2 square plus 1 into 2 power 1 plus 1 into 2 power 0. That will get it as 7. Okay. Now this is for single digit. Now how will you deal with the double digit or triple digit format? Okay. That means if you are going to write the code of 12, see, you don't have the code for 12, so you have to split the numbers as say 12 to the base 10. That is, here you are having a decimal number 12 to the base 10. So you should write it as 1 and 2 separately, and write the BCD code of 1. What is 1? 0, 0, 0, 1. What is 2? 0, 0, 1, 0. Therefore 12 to the base 10 we can write it as 0, 0, 0, 1 and 0, 0, 1, 0, 0, 0, 1, 0 in BCD format. Okay. So I think you have understood the concept of decimal to BCD conversion. Another example. If you are given a number 572 to the base 10 to convert to BCD. This is first example. Second example, convert 572 to the base 10 to the base BCD. You have to separate it. 5, 7 and 2. What is 5? It is 0, 1, 0, 1. What is 7? It is 0, 1, 1. What is 2? 0, 0, 1, 0. So answer is this is in BCD. That means 572 to the base 10. We can write it as 0, 1, 0, 1, 0, 1, 1 and 0, 1, 1, 0, 0, 1, 0. That is in BCD form. So I think you understood the concept of converting a decimal number into a binary coded decimal. Now, next part is, if you are given a BCD, how will you find the corresponding decimal number? Okay. Now, so the hint here is, you select bit by bit. You select 4 bit. Okay. You select you select segments of 4 bits and then convert it into each segment into decimal values. Convert each segment into decimal values. Okay. Example. Okay. Then BCD to decimal. Example. Convert 110 101. That is in BCD format to decimal. So here you have to take segment wise. So 110 101. Okay. So 1, 2, 3 and 4. You cut here and add 2 zeros here. Okay. Now what is 0011? 0011 is 3. What is 0101? It is 5. Therefore 110 101 in BCD you can write it as 35 to the base 10. Okay, because since there is no bits before this 11, you need to add 0 to the bit. Another example. Another example. Convert 1 0 0 0 triple 1. That is in BCD format to decimal. Okay. So we have to take a 4 bits. So 1 0 0 0 1 1 1. So 1 2 3 and 4. Cut it here. 1 2 3 and 4th bit is not there, so it is 0. What is 0 1 0 0? 0 1 0 0 is 4. What is 0 triple 1? It is 7. Therefore the answer is 47 to the base 10. Okay. Now another example, if you are having a decimal points, how do you do it? I will show an example. Convert the following into a decimal code. So how do you do it? Here what you have to do is, again here you have to segment wise in 4-bit form. Okay. And I will give the question 0 1 0 1 0 1 0 1 double 0 double 1 double 0 double 1 1 double 0 1 triple 0 point 1 0 1 to the base 2. How will you convert it into a that is to the not to the base 2, that is BCD. This is basically a BCD code. Okay. So you take 4-bit by in 4-bit segments. So I will write 0 1 0 1 0 0 1 1 1 triple 0 point 1 0 1. So here, see, this is the radix point. So after the radix point and before the radix point, you should be able to have this 4-bit segments. So after the radix point it is 1 0 1. So you add 0, that is all. Okay. So here 1 2 3 and 4. 1 2 3 and 4. That is all. Yeah. Now you got it, right? But after the radix point, you should take it as 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, and 2 raised to minus 4. That is all. Now here, how will you write it? It is 2 power 0, 2 power 1, 2 square, 2 cube. 2 power 0, 2 power 1, 2 square, 2 cube. This is 2 power 0, 2 power 1, 2 square, 2 cube. So here what is answer? 2 square, 4 plus 1, that is 5. What is double 0 double 1? That is 3. This is 8. Now here you need to add all these things. That is 2 raised to minus 1 plus 2 raised to minus 3. 2 raised to minus 1 plus 2 raised to minus 3. That comes into 0.625. This comes into 0.625. So answer is 538.625 to the base 10. Okay. So the answer is 538.625 to the base 10. I think you have understood how to convert binary coded decimal into a decimal number. Okay. Now with that I am ending with the portion of binary coded decimals. Okay. So in this lecture what I have started with is what is a code, how codes are classified, numeric codes and alphanumeric codes. What is a numeric code? The numbers which are represented as a series of zeros and ones. What is alphanumeric code? Along with the zeros and ones you have alphabets. That is known as alphanumeric codes. Then classification of numeric codes. Numeric codes are classified as weighted code. Weighted codes are again classified into binary code and BCD code. Now non-weighted codes are again classified into the types are SS3 code and example is SS3 code, gray code and 5-bit BCD code. Self-complementing codes and example is 2421 code, 5211 SS3 code. Okay, so now then sequential code 8421 and SS3 code. Error detecting you have parity code and Hamming codes. For reflective example is gray code and cyclic example is gray code. Now in this lecture, in the scope of this lecture, what we have done? We have done with weighted codes and non-weighted codes is coming only. So we have done with weighted codes. In weighted codes we have done with BCD code, and in BCD code we have taken 8421 code. Okay. Now, in the next lecture, we'll be dealing with non-weighted code. In non-weighted code, we'll be dealing with HS3 code and gray code. Okay. So once you are confident with HS3 code and gray code, then reflective, then you will be able to know what is a reflective code, what is a cyclic code. Okay. And also what is a sequential code. See here, 8421 code is also an example of sequential code. Okay. So what is a special? So one question. You already study in this lecture. You have dealt with 8421 code. How it becomes sequential? Okay. So I will try to address that question. Okay. So I will try to address that question in this lecture. Okay. So coming into this one, alphanumeric codes, you have ASCII code, FC code, and holographic code. That is an example of this code. Now, numeric codes, we are having weighted codes and non-weighted codes. So what is meant by weighted code? Here weights are given by position weighting. Okay. So if you are writing 1000, it is 8421 code. Okay. Now, what is weighted BCD code? So an example of a weighted BCD code, I have given example as 8421. So from where you got 8421, that is 2 cube, 2 square, 2 power 1 and 2 power 0 becomes 8421 code. Okay. Now, see, in binary code decimal we have 10 numbers. Okay. So we are having 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, 1, 0, 1, 0, etc. Okay. Now, how it becomes what is our question? How it becomes a sequential code? Okay. So what is a sequential code? See here in sequential code, see, this is the first number here, this is the second number. Second number will be 1 bit greater than first one. So then this is 0, 1. This is 1 bit extra. So for example, if I am doing binary addition here, for example, I will show it for 3 and 4. Okay, 0, 0, 1, 1. You add 1. What happens? So 1 plus 1 is 0. 1 plus 1 is 0 with the carry 1. Again 1 plus 1 is 0. Again with the carry 1. That is 1, 0, 0. You will get 0, 1, 0, 0. That is the BCD code of 4. That means here everything is differing by a 1 bit. Okay. Hope you have understood. That means here 011 is added with 1. Then you will get 4. So that is an example. So that is how you are getting to know that BCD code is also a sequential code. Okay. Now I have already explained how you are getting the sequential code and the corresponding decimal number, and I have shown some examples to convert a decimal number into a BCD code, as well as a BCD code into a decimal code. Okay. And I have shown the example of decimal points also, right? I have shown the examples of decimal points also. 1 second. Yeah, I have shown the examples of decimal points also. Okay. So with that, I am ending with this lecture, and in the next lecture we will be dealing with which all codes? We will be dealing with non-weighted codes, basically SS3 code and gray code. Okay. So thank you, and hoping you to be with me for the next lecture number 8. Thank you.